I've just published my game Nebula Rush. It's on Verso and you can find the code on GitHub. It's fully open source and it's free for you to use, to download and to modify. Nebula Rush is an F-Zero clone. It's something that I mentioned in a previous video, this one here. Basically, I started the game inside Claude on the web. So not in an IDE, on the web, and I did it for $0 on the free tier. I haven't subscribed to Anthropic, and that's why it was $0. I've tidied it up since this previous video, which means I did spend a little bit of money tidying it up. It's part of the subscription that I'm paying with Anti-Gravity, which is through Google. That's Google's new IDE, which is a fork of Windsurf. I wanted to check out how Anti-Gravity worked and whether it was better or different from Windsurf. I still haven't quite made my final concluding thoughts on it. It's good, and it's very like Windsurf, although it's a little bit different, and there's a few kind of quirks which make it kind of in some ways better and in some ways not. So obviously before I continue, let me remind you to like, to subscribe and to comment in order to help with the algorithm. I'll be honest, I don't really know how the algorithm works, but it seems to be that popular videos are always well liked and always got lots of subscribers and comments. That may be corroborative evidence rather than actual causality, but hey ho. Let me jump back in time just to show you how it actually looked. This is me inside the Claude.ai app in the browser. On the left was me vibing away, and then on the right is the game. It looks a bit ugly, the colours are bad, and the ship is even facing the wrong way. I showed you this in a previous video, so I'm not going to show you it in this video. It is kind of okay for $0, but it's also not really that great, to be honest. So, previous version, ugly, ship facing the wrong way, bad colours, there was no choice of ship, nor tracks, nor weather, and it's barely even a tech demo. So I've improved on all of those for the latest version. Now we have a choice of ships, we have a choice of pilots, tracks, there's even boost pads, a choice of weather, a little bit, at least there's rain, fog, and then just clear, and then time of day, morning, day, evening, and night. Here is a quick show of the tracks that are available, and this is actually just to remind me just to jump into the app itself and to give you a bit of a demo. So we'll select track. We're going to go for the first one, which is the simplest and the quickest and the easiest to show you. Let's go for day and clear because that's also the easiest to show you on a video. The other ones are also kind of cool and actually quite fun to play, but then for the purposes of this demonstration, let's go and make it easy. I'm going to go for the fastest pilot. What I want to say here is that this was all from a single prompt inside Anti-Gravity. I said, give me 8 pilots, give me pictures, give me names, give me profiles, give me stats. And it did it within a single prompt. And I thought that was actually pretty amazing. It uses Nano Banana, which is Google's image generation model. It might be Nano Banana 2.0, whatever. I can't remember, doesn't quite matter. It's one of them. This is what it gave me. And I'm actually quite surprised. Now, the images are obviously not perfectly aligned with each other in terms of style, but it's not bad. It's all science fiction at least. It's all in the right direction. Some of them are more cohesive with each other than others. I mean, maybe these ones here look a little bit anime, and this one here looks a bit off, but you know what? Actually, it's not bad. So I'm happy with that. Yes, I can fix it, and maybe I will later. Confirm the pilot. We're going to go and confirm the ship. We've got a choice of ships, and I think I'm going to go with this one, which is one of the fastest ones, and I'm going to jump into the game. Now, this is using Three.js, which handles all of the 3D models, and it handles the lighting, which you'll see at night. It's kind of hard to see it here. There's maybe a tiny bit of fog that you can see. This ship that I've got, the Speedster, is wonderfully fast in a straight line, and you can see me hitting the pink boost pads. However, it's not very good at going left to right with the lateral motion, this sort of strafing. The track is 3D. There's opponents, which is I thought was cool. I mean, it's kind of, if you think of where we were with the previous one, where the previous version was really ugly, and now we have a fairly playable game. The track looks all right. Colors are not bad. You've got 3D models. It's not perfect, but hey, given that I made this within a very short space of time, I actually think it's pretty decent. This is me on the last lap, and there, now finished second, and yeah, there's not really much more to tell you about it other than it's working, and I thought that was pretty cool. I will jump back to the presentation. Not much more to say. I wanted to tell you one interesting problem that I had, and this is something that always comes up with Vibe coding, is that there's always some problem that you hit. There's always some place where you get and where you just can't seem to get over that problem. And I hit it here, although I managed to get over it. And sometimes it's just coming at it with a new perspective. So all of the tracks, they're 3D, and so they can sort of go around in quite a complicated manner. And Gemini was creating the tracks, but it has a couple of issues. One where the track might intersect itself, and if you look in the bottom right corner, you can see where the track appears to intersect itself. There wasn't any collision, so you could fly straight through it, but you can't actually see the track on the other side. This one was fairly easy to fix, that part. What was harder to fix was sharp hairpins. So if you imagine that the track, you probably should know what a hairpin is, but if you didn't, it's whenever the track gets to a really sharp point like this. And every time that I told Gemini to fix it, it always said, oh yeah, I've done it. However, there would always still be a hairpin. It just wouldn't make the track wide enough, make the curve basically wide enough, I should say, such that it was fun to play. Because when it's too sharp, it's a bit too visually sort of disorientating on the eyes, and so that isn't fun to play. So the way that I fixed this was to ask the coding agent, give me a demo page with some calculations, calculate the gradient. It also added in the curvature, which I didn't ask for, but it added, and it actually does make sense. And then the other interesting thing was that inside anti-gravity, the agent said, okay, open the browser, and this was like a command, and you click accept, and then it says install this extension. Now be careful when you're doing this. I'm doing this on my coding machine, not on my other machine. And the IDE can connect to the extension in the browser, and it can take the data from the browser, but moreover, it can navigate within the browser. So the agent can navigate the different choices within the menu. So it can select the demo page or the demo page with the calculations, and then it takes the data for the gradient and it downloads it, essentially, or it looks at it and retrieves it. Then it says, okay, I can see where the gradient is blowing up and where the gradient is too steep and the curvature is too bad, and then it can fix it. And then it can iterate through that, going and testing, saying, okay, well, now I can see clearly, not just by the user complaining that there's a problem, okay, I fixed it, as sometimes coding agents tend to lie when they don't fix things, they think that they have. When you have like a hard number saying, okay, this is wrong, or this just isn't right, then it's got something that it can fix. And that's what it did, and that was just really cool that the agent was able to do that. It was able to open the browser, not open the browser, it has to request that, but it can look at the pages, navigate to them, and then retrieve the numbers, and then fix it. And it's doing that autonomously, basically. And I thought that was really cool. So that was an interesting problem that I was able to solve using anti-gravity. So this is going to be a short video because there is another video where I covered the basics of when I was vibe coding this. I then took it into anti-gravity, as I said. So if you can like, subscribe and comment, that would be greatly appreciated. And if you're also on GitHub, if you have a GitHub account, if you could add some stars to the repo. I'm going to try to remember to put the relevant links into the YouTube description. I'll try to do that as soon as I can. But of course, thanks for watching, and I'll be sure to show you some more interesting projects in the future, I hope. Hopefully you like that and you'll want to see more. Thanks very much.